So, so hello everyone, I am Krish Agrawal from Electrical Branch second year PDPU, and today I have made a project with the help of Arduino which is about the gas detecting alarm system. So as the name suggests, this helps us to detect the gas, and as you all know that gas detecting alarm system is nowadays used mostly everywhere, in many homes, in many hostel rooms, in many industrial areas and so on. So this can come out as a very useful thing to many people and at many places. So let's see which all components are used in this project. So we can see that the components used in this project are one gas sensor. The white color thing visible in this on the screen is the gas sensor. Then the second one is the breadboard. The board underneath the sensor is known as the breadboard. Then the Arduino board, which is at the left side of the breadboard. Then the two resistors are used. Then two LEDs, namely red LEDs and the green LEDs. Then the LCD display. Then the buzzer, which is also known as piezo. This buzzer is this black colored circular thing which is also known as piezo. There are different types of detectors used in detecting harmful gases. For example, MQ4 detector, which is sensitive for methane gas and CNG gas. MQ5 detector, it is sensitive for natural gas. MQ6 and MQ7 detector, it is sensitive for LPG gas, butane gas and carbon monoxide. And MQ8 detector, it is sensitive for hydrogen gas. Sensitivity can be adjusted using a potentiometer. Sensor has 6 pins, namely 2 H pins, 2 B pins and 2 A pins. Now we can clearly see on the screen that this is the A2 pin, then this is the H1 pin, then this is the A1 pin, then this is the B1 pin, and then this is the H2 pin, and this is the B2 pin. Now positive pin of the piezo is connected to the pin number 4 of Arduino. Negative pin of piezo is grounded as it is clearly visible on the screen. Anode of red LED is connected to pin 2. Resistor and LED are connected together. LED is never connected alone. LED is connected to ground using a resistor. As we all know that whenever we need to ground an LED, then a resistor is always used. That is why this line is mainly very much important, that an LED is never connected alone. Now we will move towards the LCD display, and we can see that there are many pins over this display. Like we can see many pins over the display. Like it is clearly visible that the ground pin, the VCC pin, the VO pin, the RS pin, the RW pin, read write pin, enable pin, then the 7 data pins, and then the LED cathode and the anode. So now let us see the LCD connections with the Arduino board. So the cathode pin is grounded. The anode pin is connected to the 5-volt input. Then the first pin is the GND pin, or the ground pin, is also grounded. Then the second pin, the VCC, is connected to the 5-volt input. Then the contrast pin, it is set to maximum by grounding it with the help of a resistor. Then the RS, or we can say the register select pin, it is connected to pin 5 Arduino. Then the read pin, or the right pin, it is connected to ground, so the read mode is activated. The enable pin, which is also known as E pin, is connected to pin 6 of Arduino. Then there are 8 data pins, out of which only 4 data pins are used, because this is a 4-bit communications. Pin 4, pin 5, pin 6 and pin 7 are used, and they are connected to the other 4 pins of Arduino. So now as we have clearly understood the simulation, and we have clearly understood this Simulink model on the Arduino, so now we will go towards the code part. As everything is clearly visible in this code, and there are not many things to understand, but we can clearly see that the liquid crystal, the LCD, it has 5, 6, 8, 9, 10, 11, and underneath it has the 4, which are the important ones, that are the red LED, the green LED, the buzzer and the sensor. As these 4 parts play a major role in the gas detection or in the safety model, and these 4 are mainly makes the safety model of our system. Then we can see the void setup, and its function is to be executed only once. Prepares Arduino to run. Then the main code comes under the void loop command, which will be continuously running. First we need, and in this we need to read the analog inputs. So it is very much important for this system to read the analog inputs. So there is a direct command in this Arduino system which can read the analog inputs, and which is the analog read. And we are clearly, as it is clearly visible in the code, we are using the analog read value. Then another important part of this code, and it is a very much important part, is to give the delay. We are giving delay after each or red LED or green LED, or when the smoke is around order. This delay is very much important for this code and this model to run successfully. Now we will start the simulation and get to know that whether our code is successful and our Simulink model is correct or not. So let us start the simulation. So let's go. So now we are starting the simulation. So now the LCD display is clearly showing us safe and all clear, and we can clearly see that out of the red LED and the green LED, the green LED is turned on and the red LED is turned off. So which means that this environment is safe, and it is all clear that there is no dense gas around the sensor, which says that we are easily safe and secure to stand or to stay over here. So now let us bring some gas near the sensor. So now we bring some gas near the sensor, and as we bring the gas closer to the sensor, we can definitely see that it is the LCD display is showing evacuate and alert, which means that the conditions or the conditions in the surroundings are not safe, and it is clearly showing the message of alert. So this is very useful, and it also shows evacuate, which says that we need to evacuate this place as soon as possible. At that time we can clearly see that out of the red LED and the green LED, the red LED is turned on and the green LED is turned off, which makes it clearly visible that which condition is currently pertaining. And this cannot be only used in these cases for safety, but it can be also used as smoke sensors in many places. So mainly its major motto is when there is a dense smoke around the sensor. So it cannot be used in places where there is very light smoke around the sensor, then it will not be very easy for sensor to read it. So and this project, as we all know, can be used in many places, in all residential areas, and also in the industrial areas, and also in the educational areas. So I hope this project was of some use to anyone, and thank you everyone for listening.